Hello everyone, today we will solve Leetcode 462, which is minimum moves to equal array element 2, and in this problem we have given an array in which we can either decrement a number by 1 or increment a number by 1 such a way that all the array elements becomes equal. We need to return the minimum number of operations we can perform such that the array element become equal. Let's explain the problem with this example. So here we see 11029 is the array element. Now what is the minimum operations you need to perform such that all the elements become equal? So just think of array in sorted order. Let's say 1, 2, 9 and 10. So let's say few elements we need to increase and few elements we need to decrease, right? So let's assume we wanted to make all the element to be 9. Then what will happen here? We need to decrease one time to make it 9. One operation will be there. Instead of that, I'll write operations here. So how many operations will be here to make it 9? One operation. How many operations will be here to make it 9? 7 operations. How many operations will be here to make it 9? 8 operations. So total number of operations will be what? 60. So you can take any number. Instead of 9 we can take 2, 1 or anything, and this way you can calculate the number of operations we need to make all the elements equal. Fine. Let's think of some solution for this. If you see elements are not in sorted order, right, then we have to find out which element we have to increase and which element we have to decrease such that the total number of operations that forms has to be minimum. So thinking the number of operations in random array is a little difficult. So first thing is, think of the element is sorted, then what you'll do, you'll try to increase the elements right from the left side and try to decrease the element from the right side, right? Then only you'll be able to get some number in the middle, and that would be minimal. Reason being, I'll prove this thing why if you choose some middle element then only it will be better. So let's prove that first. Let's say you have two number only. Let's assume this is the number line and there is a number A and there is a number B. So here let's say you have two options. Either you can choose some number C over here, or let's say you can choose some number here, let's say C1. So let's either there is other option as well to C2. So let's C1 and C2 is seems like similar. I mean to choose which middle element you should choose so that you will get the minimum number of operations to make both the element equal. So what I'll do is let's say if I'll choose C, then what would be the operation? So here to make A into C will be C minus A, and to make B into C the operations will be B minus C, which comes out to be what? C will be then that will be B minus C. This will be the operations needed. Let's think of if you go for C1, then the operation will be A minus C1 plus to make B into C1 is also B minus C. So if you see here, this will become A plus B minus 2 times C1. Let's see which one is smaller. Very simple, right? Let's see, all A and B are positive number and there is some number 0 over here. So see, what is B minus A? B minus A is something like this number over here, only this distance, right? Now what is A plus B minus C? So A will be from here to here, plus B will be from here to here, and minus 2 C. So if you remove this thing, like this part, right, 2 times C, it means that this complete part will be removed, right? But still if you see, if you compare this line versus these two, this will be more, because this will be equivalent to this one, but this part, right, this complete part is extra. So that's why I'm saying this number is bigger than this number. So from this, what we can conclude that if you have few numbers here and few numbers here, if you choose a central number to be in between to this, then only we'll get the minimum number of operations. Fine. So what would be that number? Let's think about it. Do we need the exact number or do we need any number between this? Fine. So have you seen this, how this value comes? Let me write again. Let's say there is a number A over here, there is a number B over here, and you choose a central number C from here to whom you make equivalent. So how many operations needed to make A into C? C minus A. To make B into C? B minus C. What is the total number of operations? B minus C. If you see, C is not there at all in this answer. It means that whether C is here or here or here at any point doesn't matter, right? What matters is C has to be in between this. That's it. So if you have n number, so we have to choose a central number in such a way that it is middle, in between the middle of, so that it divides half the element at the left side and half the element at the right side. So what is that number? Median, right? So what we need to do is we have to choose median of the array and then try to make all the numbers to median. Then only we'll get the minimum number of operations. The first approach will be very simple. What we'll do, first find the median. Second element, try to see how many operations needed for each element to convert into the median. Fine. What would be the time and space complexity in this approach? If you see, finding the median, how will you do that? Sort the array and n by 2th element, right? Even it doesn't matter if it is n is even or odd, because as I already said, if n is odd, in that case you'll get one number, right? There will be half of element here, half of element here, then directly you'll be able to see that key what are the gaps. But if there is number of element is even, in that case you will get two medians, right? One number over here, one number here. So which one you consider as a median? You can choose anything, right? Because any number between this doesn't matter, right? As I said here. Fine. So again, you can just directly choose n by 2th element and consider that as a median and then calculate the number of operations you need. So finding median, if you sort it and find the median element, which sorting will take n log n, and then second operation is just traversing the array and subtracting with the median element, which is n times, so total complexity would be O of n log n. Now think about the space complexity. What we are doing, we are not taking any extra space. If your sorting is not, then it will be O of 1. Fine. Let's see if you can optimize this some way or there is some improvement. So as I said over here, these middle element, which number you are choosing, that doesn't matter, right? So do you really need to choose this number? Just you need to find one number which is in between the middle, that's it. But which number it is, it doesn't matter, because in our answer it will not be present, right? Even let's say if instead of 2 number, if it's a 4 number, again there would be difference only, right? Let me just show you that thing as well. Let's say if you have 2 number, a1, a2, and then here there is b1 and b2. So if you choose some number between here, let's say c, then what would be our answer? So from left side this will be c minus a1, other will be plus c minus a2, similarly here b1 minus c, and this will be b2 minus c. If you see here this all c will be subtracted, and finally what would be the answer? b1 plus b2 minus this is called a1 plus a2. Fine. So sum of half of the right side element minus sum of the left side element. That is our answer. So from here only the second approach comes. What you can do is sort the array, right? And second step is just see this formula will be expanded again. So how you can write it: b1 minus a1 plus b2 minus b2, and similarly if n numbers it will keep on paging like this. So what it says that you can say this one to be b2, this one to be b1, or anything you can take. So it says that subtract this from here, then subtract this from here. So what will happen if you have n number like this? What you can do is, this is the first number, this is the last number. So what you can do is subtract first number from the last number. Similarly, second number from the second last number, like this. Keep on doing like this. Okay. So this way, whatever answer you will be getting, that would be your final answer, and that will give the minimum number of operations you need to do. Right? Because it doesn't matter. So what happens if number of elements are even and odd? It's fine, right? Otherwise there will be a single element, then you need not to do anything, because this number subtract from this number, that's it. If it is a even case, then this number will be subtracted from this number. Fine. So there is no problem in that case. Let's see what is the time and space complexity in this approach. So time complexity would be, first step we are doing sorting, and then we are doing just the pairwise subtraction. So sorting will take n log n, and then just the linear. So 1 of 11. Then what is the space complexity? Are we not taking? Yeah, we are not taking any extra space. It will be O of 1. Let's think of some optimization here, because if you see both the approaches having the similar time complexity, but different way to implement it. So yeah, approach 3. So here what you can do is, in first approach, just think about, firstly we are finding the median, right? And after finding the median, we just adding the difference of median with other elements, right? Then if somehow, and these are the maximum time taking steps, because we are doing, after sorting we are finding the middle element, that is the median. So if somehow we can reduce this, our overall time complexity will be reduced, right? Because second step is what? Just finding the absolute difference between each number from the median, which is taking length time. So if somehow we can reduce this will also be done. So what we can do is, as we already know that finding the median with the help of kth largest element algorithm, where we use the median of median, we can do that in O of n time, right? So in third approach, what we can do is find median. We will do with the help of median, which will give the median in O of n time, right? And then once we have the median, just find the absolute difference with each other element. Absolute difference of any element I with this median you got. Fine. In this case, what would be the time and space complexity? We are finding median of O of n, and this operation will also take O of n only. So overall time complexity will be O of n. What is the space complexity? We are not serving any extra thing. So here I am finding median with the help of the function which is called find kth element, kth largest element, where if you pass k equal to n by 2, it will give the n by 2th largest element. It means the median, right? So internally it will use the median of median and quick sort. So once we find the median, this is just a simple step. You have to find the absolute difference with the median, and that will be the final answer. Okay, thanks for watching. If there is any query or suggestion, please add into the comment section.